Hi students, let us derive third equation of motion which is also known as position velocity relation. To derive this relation, we will use same condition, that is the area of velocity time graph gives displacement. So if I write the statement at here, the area of velocity time graph gives displacement. So this shaded region is the area. Now if I can write that, so here S equal to, now I can write this area of, this is a trapezium, area of trapezium I can write OABTO. So if I can find the area of trapezium, so that gives to me displacement. So here we can write the trapezium area formula. So S equal to, that gives to displacement, the trapezium formula, half times sum of two parallel sides times height or distance between them. So this is the trapezium formula. So from our graph, how we can represent? So what are the two parallel sides from our graph? Now if you can see O to A, now if you can represent O to A is one of the parallel side, and another parallel side is at here, that is from T to B. So I can write trapezium formula S equal to half times sum of the two parallel sides. It means I need to write OA plus B to T times distance between them. So between them means distance between two parallel lines. So the distance between two parallel lines means, so this is the distance, that is from A to E. So here I can write that as A to E. So this is a simple representation. Understand it carefully. So first you should know what is the trapezium formula. The trapezium formula equal to half times sum of the two parallel sides times distance between them. Now here we need to substitute those values. Now if you can see from graph, what is the value of OA? From graph, OA value, O to A. So that is from here to here. So OA value is nothing but, for us it's the initial velocity U, and B to T. So if you can see this value from B to T at here, so this value is nothing but on the y-axis it gives to me O to V. So that is to us final velocity. So now you can you can write that BT value equal to V, and we need to know one more value, AE. So what is the value of AE? So A to E value here to here, so this is the AE value, which is also equal to O to T, because these two are the parallel lines. So this value is equal to T, so AE value also equal to T. So A to E value equal to T. Now if I substitute these values at here, therefore S equal to half OA equal to U plus B to V equal to V times A to E equal to T. Okay. Now, if you remember from the first equation of motion, so that is, if we can write from first equation of motion, we may write that from first equation of motion we may write that V equal to U plus AT. Here I need to substitute the value of the T, so I need to rewrite V minus U equal to AT. Therefore T equal to V minus U upon A. So in the place of T, if you can substitute this value from the first equation of motion, so this expression will be changes as S equal to half times U. So let me write properly, should not give any confusion. So U plus V, and the T I can get V minus U by T. Sorry, V minus U upon A. Now you can write S equal to, I can write these numerators and denominator terms. So in the numerator I can get U plus V of V minus U by 2A. On the numerator, if you can multiply by applying a formula, that is A plus B into A minus B. We know that A plus B times A minus B, which equal to A square minus B square. So on the numerator we can get the same, A plus B times A minus B, here it is equal to U square minus V square. So we need to write oppositely, V square minus U square. So I can write that V square minus U square upon 2A. Now if you can rewrite this expression, therefore S equal to V square minus U square by 2A. Now you can send the denominator term to that side, it will become V square minus U square equal to 2AS. Now this relation is known as third equation of motion. So the third equation of motion relates V stands for final velocity, and U stands for initial velocity, and A stands for acceleration, and S stands for displacement. So to derive this third equation of motion, the key statement is the area of velocity time graph gives displacement. Just like how we derive in the second equation of motion area. So in the third equation of motion, we need to derive area also. But in this case, we derive area of a trapezium. So the trapezium area half times sum of the two parallel sides times distance between them. So from our graph, the two parallel sides are O to A is one parallel side, another side equal to B to T, and the distance between them, here the between them means the distance between two parallel sides. Here AE is the distance between them. So from the graph we can substitute those corresponding the values. If we can simplify, and we reach a final expressions, so that gives us the third equation of motion, which says V square minus U square. V square minus U square equal to 2AS.